Let's look at some of the popularly used page replacement algorithms. There are various algorithms which are currently being used, but there are mainly a few popular versions, and of these popular algorithms there are various versions. So let's see the main things now, and then we shall see about the other algorithms also. So page replacement algorithm, the first one is which has been proposed but which will not be practical to implement is this optimal. Optimal page replacement algorithm. So what does it optimal page replacement algorithm mean is, so the page which will not be referred for the longest will be replaced. Optimal says that replace the page which will not be referred for longest, which means you are going to see which one will not be referred for a long time and we are going to replace it. That is called optimal algorithm, right? And then the next one is LRU, least recently used. So LRU says that replace the page which is least recently used. So which means replace the page which has not been referred for a long time. Okay, and the other important one is FIFO, first in first out. The name itself says the first one which has been got, which has been added into the main memory, that is the first one to go, right? So FIFO means the first one has to go out first, that is called FIFO. So anyway, optimal algorithm says that you look into the requests and you just see which one will not be used for a longest time, then you are going to replace it. With examples it will be clear. I don't think that with theory it will be clear. I'll take examples and explain you, but anyway, optimal says this. Okay, maybe let us say there is a supermarket. In supermarket, let us assume that there is a rack space, which means a supervisor has to choose what are the items that he could put in this space, right? Let us say one item is there is some notebook, and then there are pens, and then there are textbooks, right? So now he has to introduce a new item, right? And now by adding that new item, if he has to add the new item, one of them has to be replaced, right? Then optimal says that you see in the future, see which one will not be bought for a long time. Let us say in future, if you are sure that no one is going to buy the pens, then you can replace the pens. Or if you can see that no one is going to buy notebooks for a long time, then you can replace the notebook. Whichever is not going to be bought for a long time, you are going to replace it. But what is the problem with such a method? We can never expect what the future is. It is like this: you take some decision now based on what the future will be, right? We could never do that, isn't it? In real life also, how could we do that? If you don't know what is happening in the future, how could you make a decision now so that your future will be safe? It is never possible, right? So that is why optimal algorithm has been proposed, but it is never implemented, and it is impossible to implement practically. It is impossible, you cannot implement it. Okay, then why is optimal used is, optimal algorithm, in case if it could be implemented, will give you the least number of page faults. So whenever anyone proposes any new page replacement algorithm, what they do is they will measure its performance against this optimal algorithm, right? So optimal algorithm is used for benchmarking, which means the people will say it is 90% close to optimal, it is 70% close to optimal. So if you come up with any new or any good algorithm, or if you propose any algorithm, and if you have to prove that your algorithm is good, then you run the same simulations on your algorithm as well as on the optimal algorithm. If your algorithm is close to optimal, then people can go ahead and implement it. So it is used for benchmarking, not for implementation. And the next one is least recently used. This is very easy. So you need not look into the future, you look into the past. If someone has not been buying a good, something for a long time, then maybe you replace it. For example, if you look into the past, and one day ago someone bought the notebook, and 2 days ago someone bought the pens, and 3 days ago someone bought the textbooks, and after that there are no buyings. So this is one day ago, 2 days ago, 3 days ago, right? Then which one are you going to replace? This textbook, right? Because it has been not bought for a long time, in the past, not in the future. So it is practical and it can be implemented. There are various variations of least recently used. We shall see them also. Okay, the various variations. But anyway, from gate point of view, variations are not important. Only the main algorithms are important, and even implementations are also not important. Let's see the problems. You'll understand it. And next one is FIFO. First in, first out says that you just see the order in which you have placed them, which means maybe in the supermarket notebooks were introduced first, and then pens were introduced, and then textbooks. Then whichever has been introduced first, that one has to go out first. So which will go out now? Notebooks will go out. Why? Because notebooks were the first one to enter into the rack in supermarket, right? So this is how we can implement these algorithms, right? So let's see some problems on this now.